This is question 6 from paper 2-1 from the Cambridge International Education Exams Summer 2020. You can find a link to an image of this question in the description below the video, and I recommend you try the question before looking at my solution. This is a pretty tough question, and so this video might be a little longer than usual. Part A asks us to prove this long line here. I guess I'll read it out. Sine 2 theta multiplied by the cosec theta minus the sec theta, or secant it's also called, is defined as, or is equal to in all cases, square root of 8 multiplied by cosine of theta plus pi over 4. Now this 3 equals, I just mentioned there, it's just like an equals. You can treat it just like an equals. It just means there's not one answer for theta that's correct here. All numbers for theta will still mean that this is equal to this. If we drew these two pictures out, I don't know what it'd look like, they would be identical. They'd be on top of each other. There'd be just one picture on either side. Either way, all you need to do is treat it like an equals, make the left look like the right, and you'll get full marks, or right like left, whichever way you want. So I'll start working on the left hand side here, and I'll start breaking it up. First thing I can see is sine 2 theta. 2 theta is different than all the others. Theta, theta, theta. So let's break that up. We have a rule for this. It'll be given to you in the formula table. Let me just remind myself. Yeah, 2. So it's 2 sine theta cosine theta. That's just this guy here. That's just straight from a formula tables. It's something you'll be given in the exam. So if you want to break this up, it looks like this. You can look up the proof for it. It's not too complicated, that one. Now the next thing I would look at is what's inside here. Oh, this could be confusing for some students. Cosecant, what is this? SEC and co-SEC. Well, really, it's just another way of writing 1 divided by sine theta minus 1 over cosine theta. Certain places in the world, you wouldn't even write these symbols. You just write it like this. Personally, I think, why complicate it with this? Are you saving that many extra strokes? One line and one line to save these two letters? I don't know. I think I'd rather just keep it like this. Okay, so that's simplified the left a good bit. Let's try and mash this together a little bit. Inside the bracket, I think, if we add these together, two fractions, cross multiply. So we'll get cosine, yeah, let me write it all out, I suppose. 2 sine theta cosine theta. So if we cross multiply this, we get cosine theta minus sine theta, all divided by the two bottom rows multiplied. Sine theta cosine theta. And that's good because that's the same as this. So we can just cancel it. So the left hand side has now come down to 2 multiplied by cosine theta minus 2 multiplied by sine theta. So we've got it quite simple, the left. Doesn't quite look like the right. It's something you maybe should notice, but we are often asked to combine a cosine and a sine to look like a cosine or a sine. Combining two things to look like one. We do this mostly because of integration, and as I can see from part C of this question, that this involves integration as well. Now, there might be more you might be able to play around with this in a better way, but I think the easiest way for me to show this is for me just to play around with the right hand side now and make it look like this left hand side. Because that's the best way anyway I know to combine two trigonomic functions like that into one. I guess an answer. I guess to combine these, I'd often just write A cosine theta plus B, something like that. But I don't need to guess it this time because I already have that template here. Anyway, I'm just going to take the right hand side now and play around with it and try and make it look like this. So to change this, I'm going to use the formula that we've been given, cosine alpha plus beta, or sorry, A plus B. So this would be one of our famous formulas, and this is just equal to cosine alpha, sorry, I keep saying alpha, cosine A sine B minus, sorry, that should be cosine here, cosine A multiplied by cosine B minus sine A sine B. Apologies if you can't see that. It should be in your own formula tables if you have one. They're given to you in the back of an exam. So I'm just going to use this information here because this is just A and B. So this is the same as square root of 8 multiplied into cosine theta, cosine theta cosine pi over 4 minus sine theta sine pi over 4. And let's clean this up a little bit, and maybe you've already noticed something here, but this actually is starting to look a lot like here. Some students might be unsure on that, but trust me, it is. We have a cosine theta, a number, and a number. We have cosine theta and a number. That's quite similar. We have sine theta and a number, sine theta and a number. So let's write this again. If I write it like this, square root of 8 cosine pi over 4 cosine theta. So I've just multiplied the 8 in here, and I wrote this guy in front. I just switched them around really, just to make it look more like this, to be honest. Minus square root of 8 sine pi over 4 sine theta. So now it looks very much like it. We have cosine theta and a number, cosine theta and a number, sine theta and a number, sine theta and a number. So really all I need to do is show that this number is equal to 2 and show that this number here is equal to minus 2. And you can just do that by putting that in a calculator and writing out 2 cosine theta. The examiner will give you full marks for that, but I'd like to do a little bit more than that. Instead of using a calculator, I'd like to point out that cosine pi over 4, something, again, we're given this in our exam in a formula table, that's equal to 1 over square root of 2, and also so is sine pi over 4. Square root of 2, not 2 squared. And that's 45 degrees, by the way. That's why they're the same. They're both the same at that point. So what do we have here? We have 8, square root of 8 divided by square root of 2. Well, that's square root of 4, which is 2. 2 cosine theta, and this is also 2. Our minus was here. 2 sine theta. So there we go. That is equal to that. That's you're finished. The left now looks like the right. Let me try that again. The right now looks like the left. So that is part A finished. Part A was the hardest part of that question. It was in fact most of the marks for that question as well. So don't worry if you got a little stuck in that. The good news is part B and C, it's okay if you got this wrong, because they've given you all you need to still do part B. I'll go ahead and rub this out, and we'll go ahead and try part B. I'll leave this line here, because this is the information we need. Okay, part B asks us to solve an equation. They tell us that sine 2 theta multiplied, but basically this. They tell us this left-hand side here, and they tell us that's equal to 1. So they say this is equal to 1. Now, here's the trick here, and it's a trick that happens in most questions in exams. Don't do what they tell you if they've already told you that this thing equals something that looks easier. So instead of putting this equal to 1, let's just go ahead and try and solve square root of 8 cosine. Did they use an x instead? No, they used theta. Cosine theta plus pi over 4 equals 1. So let's try and solve this equation, because that's going to be much easier than trying to solve this one. But of course, that one is this one. We just shown that. Okay, so let's play around with this. We'll get cosine theta plus pi over 4 is equal to 1 divided by square root of 8. Let's take the inverse cosine of both sides. We'll get theta plus pi over 4 is equal to the inverse cosine of 1 over square root of 8. The calculator will just give us a number for this. But remember, when we're dealing with cosines, let's draw a cosine here, and it comes down this part of the world. We don't just get one answer. Let me see. Square root 1 divided by square root of 8. That's bigger than 0, less than 1 anyway. Somewhere about here, let's say. So this would be an answer. The calculator will give us this one. But so is this answer. So is this answer. So is this answer. So we look at the question again, and they tell us that theta here is going to be between 0 and 90 degrees. 0 and pi over 2, which is here. So it's going to be in this part. So you might think, oh good, that must be this answer then. Be careful, be very careful. This picture I drew here is theta plus square root of plus pi divided by 4. We're not looking for that. This is going to give us a different answer here. Well, actually it's not in this case, but often it is. So be very careful. This picture is of this cosine. And inside that cosine is theta plus pi divided by 4. Whereas the answer we're looking for is just theta. So they tell us theta is between 0 and pi over 2. They don't tell us what this is. So this answer could still be any one of these. Actually, this is probably the safest way to do this. Let's just get all of these answers here. So if we put this into a calculator, we'll get this answer here. And that is, let me check my notes, it's 1.209. I'll use 4 significant figures, just so I don't lose them when I'm rounding off on this one. That's this answer, but maybe it's this answer. Maybe this answer could be right. So if this is 1.2, this is minus 1.2. Minus 1.209. You don't have to do this if you're good enough at understanding how these work. Like personally, I wouldn't have wrote all these out, and better students might. But I'd expect middle and lower students to write all of these answers out. Well, not all of them. There's infinite, but many of them. Just to give you an idea. So this will be 1.2. This will be minus 1.2, and there'll be more down this way. And maybe we'll do one more. So this answer here, this is 2 pi. So this gap must be the same as this gap. So this last one must be 2 pi's, which is about 6.3 minus take away minus 1.2. So I actually don't have the number there, but 6.3 minus 1.2. I'll just write roughly. Roughly 5.1. I'm not going to need it, so it doesn't really matter. So we get many answers. There's more than this as well. There's much more than this. Whereas the one we're looking for is just theta. So theta is equal to all of these. Let's see, minus 1.209 minus pi over 4. Or it could be equal to this one, 1.209 minus pi over 4. Or it could be equal to this one, 5.1 minus pi over 4, or it could be equal to any of these other ones here. Okay, so now if you put a few of these in, you'll notice that only this one here is between 0 and pi divided by 2. So this answer is going to be too small, it'll be a minus. So we could have actually seen that much earlier. This number, take away pi over 4, will be even more minus. This number, take away pi over 4, this much of a space here, won't get us into this world. So this one's bound to be wrong as well. That one's going to be too small. This one's going to be too big. The one that a student probably would have got from a calculator anyway is going to be correct. But just be careful, because most questions that will not work out as nicely. So just put this in a calculator and you get, in decimal places, 0.424. That's the correct answer there. You didn't have to draw any of that. You didn't need these multiple ones. I was just trying to explain a little more to you. I don't think I did the best job there. So if you have any follow-up questions, please put them in the comments below and I'll do my best to answer those parts. Now there is one more part left, and it's quite difficult. So let me rub this out and we'll move on to part C. Okay, part C asks us to do this integral here. So we want to integrate this big mess of a question. And this is how we mostly do integration of trigonomic equations or expressions. We first do what we did in part A. We first have to take this and go, oh, I need to make something easier out of it. So that's what we've done in part A. Now it doesn't look the exact same, be very careful. There's an x instead of a 2 theta, but this is 2 theta, this is half of this. This is half of this. So they are actually equivalent. They are the same. Instead of writing all of this, I can write square root of 8 cosine plus pi over 4. The only slight difference will be, it won't be theta, it won't be x. So theta was the same as theta. So whatever is, this is equal to, it's going to be the same as this guy here. These two guys here. So it's x over 2. Just be lots of students would have wrote x there and they would have lost marks. The examiner would have given them some marks if they did the rest correctly, but they would have lost marks there. And dx is still the same. Okay, so instead of this really hard question, I can do this question. But this is still difficult in its own right. There's a couple of ways to do it. Some students are really good at doing this in their head actually. They guess an answer. For example, the integral of cosine will be sine. So they say, ooh, let's differentiate sine, something that looks like this. And they get an answer, and actually, again, some students are really good. Just use the chain rule, a half will appear, or inverse of a half, I guess. Yeah, I think the answer would be a 2 will appear. We won't do it that way. So if you're good enough to do that, well done. You're probably not watching this video. You've probably already got the question answered. So I'll show you a little more methodical way to do it. So let's start. I don't have much room, so I'm going to cheat a little. I know you guys can't do, you'll have to write a whole new line. But instead of square root of 8, I'll just write square root of 8 here. Because it's a constant. Numbers can just be taken outside. Okay, what's making this question difficult now is this. Because we are able to do the integral of cosine x dx is just equal to sine x plus the constant, I suppose. So the only thing making this difficult is what this bracket here. So let's cheat again, and will you put u? It's just the letter we often use for this substitution. U is equal to x over 2, x over 2 plus pi over 4. Wouldn't it be great if instead of this was here, what if just u was there? That's the idea here. Because again, just like this, we know what the integral of cosine x dx, that means we know what the integral of cosine u du is. So, but we wouldn't have du, we'd still have a dx. So here's how we do it. We put u equals to that, and then we differentiate. I don't really want to differentiate, I just want to find out what du is equal to. Or I want to find out what dx is equal to get rid of this guy. Actually, yeah, let me skip ahead before I do this, because what I've done here, I've replaced this, I want to replace this with square root of 8, the integral cosine u and du. I want du here. I can't do a question about u without du. So that's fine. I can easily put u in because I've just said u equals this. But how do I get rid of dx? That's what I'm doing down here. Okay, so differentiate this. The derivative of x divided by 2 is just, another way to write that would be a half multiplied by x. So the derivative of x multiplied by half is just a half, and the derivative of a constant is 0. So it's gone. So we have something quite simple here. So we break this up. We have du is equal to, put the dx over here. We'll rearrange it any way you want, really. I'll put dx on its own. So let's get dx over here and then bring the 2 over there. So dx is equal to 2 du. So instead of dx, I could just write 2 times du. 2 can go here or move all the way out to the front. It's a constant. Let's get it out of the integral. Move it all the way out to the front. Okay, so this is a much easier question than this, which in its own right was an easier question than this one. So I can just write the answer to this. It's 2 square root of 8. The integral of cosine is just sine u, and we better remember a constant. Now, some students do all this hard work and they leave this answer. This is wrong. Remember, I or you made up this letter, U. They didn't ask the question. The question didn't ask about U's. There was X's in the question. So let's put back in our substitution. Because that's all we did. We substituted while we made the work easier. Once we put it back at the end, nobody's any the wiser and nobody will care. So this is, let me separate some of this. This is equal to 2 square root of 8 sine, what was our replacement? It was x over 2 plus pi over 4. And again, we have some sort of constant here at the end. That's our answer. That's our answer. Remember, the constant appears because integration, it's backwards differentiation. So if I differentiate this, I will get this. Well, I'll get this, which we now know is equal to this. And if I differentiate some constant c, it disappears. And look, there's nothing here. So that's where that c came from. Okay, that's full marks. That's the answer to part C. If you have any follow-up questions, it was a really hard question, so don't be ashamed to have any. Ask them in the comments below. I'll do my best to answer them, or maybe somebody smarter is in the comments that can give you a better answer than me. Either way, thanks for watching and have a great day.